It started as routine seismic tremors beneath Mount Semeru, the kind Indonesia's volcano monitors see every day. 3.676 meters above the Java Sea, the highest volcano on the island had been quietly rumbling since 1967, releasing small puffs of ash and gas like a geological pressure valve that never quite closes. But in the past week, something fundamental changed. At precisely 12:12 a.m. on November 3, 2025, Mount Semeru shattered the pre-dawn silence across East Java with an explosive burst that sent ash plumes nearly a kilometer into the sky. What should have been an isolated event became a sequence. November 4th brought another eruption. November 6th at 6:07 a.m., another. November 7th at 1:45 p.m., this time accompanied by something far more dangerous. Lava avalanches now cascade 2.5 kilometers down Java's southeastern slopes, carving fresh scars into terrain that killed 48 people in 2021. The ground that swallowed entire villages is stirring again, and this time scientists monitoring the mountain's every tremor can't predict when it will stop. The Indonesian Volcanology and Geological Hazard Mitigation Center has set the alert level at waspada, watchful. But that clinical term barely captures what's actually happening in the shadow of a mountain that has never learned to sleep. The first indication that Mount Semeru was entering a new phase of activity came not from the mountain itself, but from the seismographs positioned around its base. Throughout late October 2025, monitoring stations detected subtle changes in the volcano's internal rhythm. Micro-earthquakes occurring at slightly different intervals, gas emissions shifting in composition, ground temperatures rising by fractions of degrees. For volcanologists studying Semeru, these variations represent the mountain's way of communicating. Every tremor, every gas release, every thermal shift provides clues about the massive geological processes occurring thousands of meters below the surface. After nearly 6 decades of continuous monitoring, scientists have learned to read Semeru's moods with remarkable precision. But even the most sophisticated monitoring equipment couldn't predict the intensity of what began unfolding on November 3rd. At exactly midnight local time, Mount Semeru erupted with explosive force that registered on seismographs across East Java. The blast sent volcanic ash 800 to 1,000 meters above the summit. Not catastrophic by volcanic standards, but significant enough to trigger immediate alert protocols. What made this eruption particularly concerning wasn't its size, but its persistence. Within 24 hours, another eruption followed. Then another on November 6th at 6:07 a.m., powerful enough to wake residents in Lumajang and Malang regencies, who had grown accustomed to sleeping through Semeru's typical nighttime rumblings. Each successive blast deposited fresh volcanic material on the mountain's southeastern slopes, loose, unstable debris that would soon become ammunition for something far more dangerous. The November 7th eruption at 1:45 p.m. marked the moment when Semeru's activity shifted from concerning to actively threatening. This blast not only produced another ash plume reaching 4,676 meters above sea level, but triggered the formation of a lahar, a fast-moving volcanic mud flow that raced down the mountain's drainage channels with devastating efficiency. By evening on November 7th, the lahar had reached Jugasari village in Candipuro district, where it collapsed approximately 6 meters of roadway. The road failure wasn't just an infrastructure problem. It cut off the primary evacuation route for several rural communities, effectively trapping residents between the mountain above and the compromised transportation network below. Local officials immediately began coordinating with the Indonesian Volcanology and Geological Hazard Mitigation Center to assess the full scope of the threat. Satellite imagery revealed lava avalanches extending up to 2.5 kilometers southeast from the summit, following the same drainage patterns that had proven deadly in 2021. The volcanic flows carved new channels through forest and farmland, creating a network of potential pathways for future lahars. The November 9th eruption at 3:06 p.m. confirmed what volcanologists had begun to suspect. Mount Semeru had entered a sustained eruptive period that showed no signs of immediate decline. But that's only part of the story. To understand why Mount Semeru poses such a persistent and unpredictable threat, it's necessary to examine the extraordinary geological forces that created and continue to power this volcanic system. Semeru sits at one of the most tectonically active locations on Earth, the boundary where the Indo-Australian plate drives beneath the Eurasian plate at a rate of approximately 7 centimeters per year. This process, known as subduction, creates conditions that are simultaneously creative and destructive. As the oceanic Indo-Australian plate descends into the Earth's mantle, intense heat and pressure melt the rock, creating magma that rises toward the surface through fractures in the overlying crust. The result is the Indonesian archipelago's chain of volcanoes, stretching across 17,000 islands and including some of the most active volcanic systems in the world. What makes Mount Semeru particularly dangerous among Indonesia's 130 active volcanoes is the composition of its magma and the unique way it releases accumulated pressure. Unlike explosive volcanoes that periodically blow their tops in single catastrophic events, Semeru operates as what volcanologists call a continuous degassing system. Since beginning its current eruptive cycle in 1967, the mountain has released small but persistent amounts of volcanic material almost daily. This constant activity creates what researchers term a deceptive equilibrium. Local communities grow accustomed to Semeru's regular ash emissions and minor lava flows, developing a tolerance for volcanic activity that would seem extraordinary elsewhere. Farmers work fields within sight of active lava flows. Children attend schools where volcanic ash occasionally dusts playgrounds. Life continues in the shadow of a mountain that never truly rests. But this apparent stability masks the complex and unpredictable dynamics occurring beneath Semeru's slopes. Recent seismic data reveals a volcanic system under continuous stress, with magma chambers that expand and contract based on factors scientists are still working to understand completely. Small changes in regional earthquake activity, variations in groundwater levels, or shifts in atmospheric pressure can trigger eruptions that exceed the mountain's typical baseline activity. The southeastern slopes where current lava avalanches are flowing represent a particularly vulnerable zone due to both geology and geography. Semeru's cone sits atop older volcanic deposits that create a naturally unstable foundation. When new volcanic material accumulates on these slopes, it forms what volcanologists call angle of repose formations. Volcanic debris balanced at the steepest angle that gravity will allow. Any disturbance, additional volcanic material, heavy rainfall, or seismic activity can trigger massive avalanches of hot volcanic debris that race down the mountain at speeds exceeding 60 kilometers per hour. These pyroclastic flows and lava avalanches follow the path of least resistance, which invariably leads them into the river valleys that provide drainage for the mountain's massive bulk. The transformation of volcanic debris into lahars represents perhaps the greatest immediate threat to communities around Mount Semeru. When hot volcanic material meets water, whether from rainfall, river flow, or groundwater, it creates a concrete-like slurry that flows with devastating efficiency down established drainage channels. Unlike lava flows, which move slowly enough for evacuation, lahars can travel 13 kilometers from their source in a matter of hours. Current satellite thermal imagery shows sustained heat signatures across Semeru's southeastern face, indicating that the volcanic system continues to produce and deposit fresh material. Seismic monitoring stations detect ongoing micro-earthquake activity that suggests continued movement of magma beneath the mountain. Most concerning for volcanologists, ground deformation measurements indicate that certain areas of Semeru's cone are expanding, a potential sign that pressure within the volcanic system continues to build. Yet what comes next could be even worse. December 4th, 2021 began like any other day in the villages scattered across Mount Semeru's lower slopes. In Lumajang Regency, farmers prepared for the morning harvest in fields fertilized by centuries of volcanic ash. Children walked to school along paths that wound between houses built from the same volcanic stone that occasionally fell from the sky. Market vendors arranged their stalls while keeping one eye on the mountain above, as their families had done for generations. Mount Semeru had been particularly active that week, producing larger than usual ash plumes and more frequent lava flows. But this was Indonesia's highest volcano on Java. Activity was normal. Local residents had developed an intuitive understanding of their mountain's moods, learned through lifetimes of living in its shadow. They knew the difference between routine rumbling and genuine danger, or so they believed. At 2:46 p.m., Mount Semeru erupted with unprecedented violence. Within minutes, pyroclastic flows, superheated avalanches of gas, ash, and volcanic debris began racing down the southeastern slopes at temperatures exceeding 800 degrees Celsius. Unlike the predictable lava flows that move slowly enough for evacuation, these pyroclastic flows traveled at speeds approaching 100 kilometers per hour, following drainage channels that led directly to populated areas. The first communities to experience the approaching disaster heard it before they saw it. Survivors later described a sound unlike anything in their experience. Not the rumble of volcanic explosion, but the roar of approaching flows that resembled freight trains, accelerating through their valleys. Some villagers had only minutes to escape. Others never had the chance. In Cura Kobokan village, home to several hundred families, the pyroclastic flow arrived with virtually no warning. Houses built from traditional materials, wood, bamboo, corrugated metal, offered no protection against the superheated gases and debris. Within an hour, the village had essentially ceased to exist. But the pyroclastic flows were only the beginning of the 2021 disaster. As volcanic debris accumulated in river channels already swollen by seasonal rainfall, massive lahars began forming. These volcanic mudflows moved with the consistency of wet concrete, but the speed of flash floods, following established waterways that had carried runoff from Mount Semeru for thousands of years. The lahars grew in size and power as they incorporated additional debris, transforming from volcanic runoff into geological bulldozers, capable of moving multi-ton boulders and destroying anything in their path. The Besuk Kobokan river system, which drains much of Semeru's southeastern face, became a highway for destruction. Villages that had safely existed along these waterways for generations found themselves directly in the path of flows that reached depths of several meters and moved faster than people could run. Emergency responders later discovered that traditional evacuation plans proved inadequate when disaster moved faster than evacuation routes could empty. The volcanic flows followed natural drainage patterns that had been carved by centuries of similar events, creating a geological inevitability that human preparation struggled to match. When the immediate danger finally passed, the scope of the destruction became clear. 48 people had died, many overcome by the toxic gases that preceded the pyroclastic flows. Over 2,900 homes lay damaged or completely destroyed. Entire agricultural areas had been buried under meters of volcanic debris that would take years to clear. Perhaps most tragically, many of the casualties occurred among residents who had successfully evacuated during previous volcanic emergencies. The 2021 eruption exceeded all historical precedents for Mount Semeru's behavior, creating conditions that even experienced volcano watchers had never encountered. In the aftermath, volcanologists studying the disaster identified several factors that contributed to its unprecedented severity. Unusually high rainfall in the weeks preceding the eruption had saturated volcanic deposits on Semeru's slopes, creating conditions ideal for lahar formation. The eruption itself occurred during afternoon hours when villages below were most active. Most significantly, the eruption sequence produced more volcanic material than monitoring systems had predicted, overwhelming drainage channels that had previously handled Semeru's typical output. And now, scientists fear history may be repeating itself. The eruption sequence that began on November 3, 2025, displays troubling parallels to the conditions that preceded the 2021 disaster. Multiple eruptions within a single week, lava avalanches extending beyond typical boundaries, sustained seismic activity, and lahar formation during Indonesia's rainy season. These patterns echo the warning signs that proved insufficient to prevent catastrophe 4 years ago. But there are also significant differences that make the current situation uniquely challenging for emergency planners and local communities. The November eruptions have occurred during a period of increased rainfall across East Java, creating ideal conditions for lahar formation. Every new deposit of volcanic material on Semeru's slopes becomes potential ammunition for future mudflows. Unlike the 2021 disaster, which resulted from a single catastrophic eruption, the current sequence represents sustained volcanic output that continuously adds unstable debris to an already dangerous landscape. Indonesian authorities have responded by establishing comprehensive exclusion zones that extend 8 kilometers southeast from Semeru's summit and 500 meters from riverbanks up to 13 kilometers from the mountain. These zones encompass the basic Kobokan drainage system, where the most dangerous lahars are likely to occur, as well as tributaries including Basic Bang, Basic Kembar, and Basic Sat that have proven vulnerable to volcanic flows in previous emergencies. But exclusion zones only work if the volcanic system respects boundaries established by human planners. The November 9th eruption at 3:06 p.m. occurred during broad daylight hours when agricultural communities below would have been most active in their fields. While no casualties have been reported from the current eruption sequence, the timing demonstrates how quickly conditions could deteriorate if future eruptions exceed the scale of recent activity. Current monitoring data reveals several concerning trends that distinguish this eruptive period from Semeru's typical baseline activity. Seismic stations detect earthquake swarms occurring at depths consistent with magma movement within the volcanic system. Thermal infrared imagery shows sustained heat signatures across the southeastern slopes that haven't diminished since the eruption sequence began. Most significantly, ground deformation measurements indicate continued expansion of certain areas near Semeru's summit, suggesting ongoing pressure buildup within magma chambers. Dr. Hanik Humaida, head of the Indonesian Volcanology and Geological Hazard Mitigation Center, described the current situation as dynamic and requiring continuous assessment. This scientific language reflects the fundamental uncertainty that characterizes volcanic prediction. Even the most sophisticated monitoring equipment cannot definitively predict when routine volcanic activity will transform into something catastrophic. Local officials in Lumajang Regency have implemented emergency protocols developed after the 2021 disaster, including improved communication systems and pre-positioned evacuation equipment. But these preparations face the same fundamental challenge that has defined volcanic emergency planning throughout history: the speed and unpredictability of volcanic processes that can transform safe areas into danger zones within minutes. The communities most at risk from Mount Semeru's current activity are the same villages that rebuilt after 2021. These residents possess intimate knowledge of volcanic dangers, having lived through the deadliest eruption in Semeru's recorded history. Yet they also understand the economic and cultural impossibility of permanent evacuation from lands their families have worked for generations. The fertile volcanic soil that makes this region deadly also makes it irreplaceable for agriculture. Coffee plantations and vegetable farms that depend on nutrient-rich volcanic ash provide livelihoods for thousands of families who have few alternatives outside the shadow of Mount Semeru. Current meteorological forecasts predict continued rainfall across East Java through the remainder of November and into December. Precisely the conditions that proved catastrophic in 2021. Each rainstorm transforms newly deposited volcanic material into potential lahar sources, creating a situation where weather patterns become as important as volcanic activity in determining public safety. Because what happens next could rewrite maps. As this analysis is being prepared, Mount Semeru continues its pattern of sustained volcanic activity that began on November 3rd. Satellite imagery updated hourly shows ongoing thermal signatures across the southeastern slopes. Seismic monitoring stations detect persistent micro-earthquake activity that indicates continued movement of magma within the volcanic system. Weather stations predict additional rainfall that could transform any new volcanic deposits into fast-moving mud flows capable of reaching populated areas within hours. The Indonesian Volcanology and Geological Hazard Mitigation Center maintains its Waspada alert level, a designation that reflects as much uncertainty as scientific caution. After nearly 6 decades of continuous monitoring, volcanologists understand Mount Semeru's general behavior patterns, yet the mountain continues to surprise even the most experienced observers. What makes this volcanic system particularly unnerving for both scientists and local communities is its fundamental persistence. Unlike volcanoes that erupt catastrophically, then return to extended periods of dormancy, Mount Semeru never truly sleeps. It simmers constantly, releases pressure gradually, produces regular ash emissions and minor lava flows. Then occasionally, without adequate warning, overwhelms the very communities that depend on its fertile slopes for survival. Expert opinions on the current threat level vary significantly, reflecting the genuine uncertainty that characterizes volcanic science. Some volcanologists point to the relatively controlled nature of recent eruptions, ash plumes that remain below 1,000 meters, lava flows that follow predictable drainage channels, seismic activity that suggests orderly pressure release rather than catastrophic buildup. These scientists argue that Semeru may be safely venting accumulated pressure through the current eruption sequence. Other researchers note the disturbing similarities between current conditions and the lead-up to the 2021 disaster. Multiple eruptions within a short time frame, sustained lava avalanche activity, lahar formation during rainy season, and most concerning ground deformation measurements that suggest continued pressure accumulation within the volcanic system. These scientists advocate for enhanced evacuation preparedness and expanded exclusion zones. The debate reflects a fundamental limitation in volcanic prediction that affects emergency planning worldwide. While monitoring technology can detect changes in volcanic systems with remarkable precision, the translation of that data into reliable predictions about future behavior remains an inexact science. Volcanoes operate according to complex interactions between geological processes, atmospheric conditions, and historical patterns that even supercomputers struggle to model accurately. For the approximately 200,000 people living within potential impact zones around Mount Semeru, this scientific uncertainty defines daily existence. Emergency planners can establish evacuation routes, monitoring stations, and communication systems, but they cannot eliminate the fundamental unpredictability of volcanic processes that have shaped this landscape for millennia. Local communities have developed their own systems for assessing volcanic risk based on generational experience with Mount Semeru's behavior. Farmers observe changes in the mountain's appearance, gas emissions, and seismic activity that may not register on scientific instruments. Market vendors adjust their schedules based on ash forecasts. Parents teach children to recognize the sounds and signs that indicate when normal volcanic activity is becoming dangerous. But the 2021 disaster demonstrated the limitations of even experienced observation. The eruption that killed 48 people exceeded all historical precedents for Mount Semeru's behavior, creating conditions that surprised both scientific monitoring systems and local communities that had successfully coexisted with the volcano for generations. The current eruption sequence continues with no clear resolution in sight. Each day brings new seismic data, updated satellite imagery, and meteorological forecasts that add pieces to a puzzle that may never be completely solved. Mount Semeru holds its geological secrets close, revealing its intentions only through eruptions that serve simultaneously as communication and threat. What remains certain is that the mountain's story continues to unfold. The volcanic forces that created Mount Semeru operate on timescales that dwarf human planning and preparation. The next eruption, whether tomorrow, next week, or next year's Sojin Kwairabichior, will represent another test of whether human adaptation can match the power and unpredictability of geological processes that shaped this landscape millions of years before people arrived to call it home. Mount Semeru continues to write its geological story in ash, lava, and seismic tremors that remind us daily of the dynamic forces beneath our feet. For the communities living in its shadow, for the scientists monitoring its every movement, and for anyone seeking to understand the relationship between human civilization and natural forces, this mountain serves as both teacher and warning. The earth beneath Mount Semeru never stops moving, never stops changing, and never stops demanding our attention and respect. In a world where natural disasters feel increasingly frequent and intense, Mount Semeru represents both the specific dangers facing Indonesia and the universal challenge of coexisting with a planet that remains largely beyond our control. Stay informed about volcanic activity in your region. Support scientific research that improves our understanding of geological hazards. Remember that the ground beneath our feet tells stories that stretch across millions of years, and our role is to listen carefully to what it continues to teach us. The mountain's next chapter is already being written. Whether we're prepared to read it may determine how that story ends.